Right. Hope you can hear me, right? Shall we start? Right. Okay. Then let's start the class. Right. So this one is the note that we discussed previous day, and okay. So we will let's take few minutes and then talk about the things that what we have discussed in previous day. So we can move to the today's part, right? Discovery of X-rays. මතකද discovery of X-rays එතනින් තමයි අපිට වැඩේ පටන් ගන්න තියෙන්නේ. Discovery of X-rays. So what we need to remember in here is, right? So we need to remember, okay, discovery of X-rays. එතනින් ඉඳලා පටන් ගමු. Discovery of X-rays. So we need to remember the name of the scientist, right? We need to remember the name of the scientist who discovered the X-rays. Rontgen, right? Hope you remember. Rontgen discovered the X-rays. Rontgen discovered the X-rays. We need to remember the name of the scientist who discovered the X-rays. Right. Rontgen discovered the X-rays. Okay. So remember the name Rontgen. He discovered the X-rays. And how he discovered the X-rays? Right. X-rays were discovered in 1895. The German scientist Rontgen. Experimenting with the cathode ray tube. This is also we need to remember. Experimenting with cathode ray tube. Experimenting with the cathode ray tube. Experimenting with the cathode ray tube. Experimenting with the cathode ray tube. Right. Rontgen noticed a glowing light on a screen coated with barium platinocyanide, even though the tube was covered with black cardboard. Covered with black cardboard. Right. Again, yang Rontgen එනවා ඇවිල්ලා cathode ray tube එක ගැන අපි දන්නවනේ, right? Cathode ray tube එක. එතකොට Rontgen right. Rontgen discovered, right? Rontgen discovered, right? Even though the cathode ray tube was covered with the black cardboard, he discovered a new type of rays, right? So Rontgen comes and he did certain experiment. I think this is cathode ray tube. This is the cathode ray tube, right? So here also you can observe the cathode ray tube, and then here cathode ray tube, right? Even though this cathode ray tube was covered with a black cardboard, right? He covered this with the black cardboard, and then he noticed that the certain rays strike on the nearby the barium platinocyanide coated screen. A new type of rays he observed, right? From that observation, now there is a new type of rays and it penetrates through the cardboard. It penetrates through the cardboard. So he named these rays as X-rays since do not know the properties or do not know anything about that rays, therefore name as X-rays, since we do not know the things about the X-rays. And then later he got the first, right? Later, right? On December 22, 1895, he took the first X-ray photograph. He took the first X-ray photograph of his wife's hand, clearly showing her bones and wedding ring. මේ කියන්නේ මුලින්ම අර දන්න ටිකක් හොයාගෙන wife ගෙන් තමයි check කරන්නේ. wife ගෙන් තමයි අරගෙන බලන්නේ. මේ wife ගේ අතේ තමයි එයා අරගෙන බලන්නේ මේ X-ray එකක්. මොකද වෙන්නේ කියලා. හරිද? So that is the first X-ray. Now you may heard about many things regarding the X-rays and all the things, but here is the point where that process of taking X-rays initiated, right? And what is the name of the scientist? Roentgen. Name of the scientist is Roentgen. So keep in mind. And he named these rays X-rays where X mean unknown, right? X-rays become very important in medicine because they allow doctors to see inside the human body without surgery. It means power. So here we need to remember something, right? X-ray can penetrate human flesh. X-rays can penetrate human flesh. Write it down. X-rays can penetrate human flesh. X-rays can penetrate human flesh. Right? X-rays can penetrate human flesh. X-rays can penetrate, right? X-rays can penetrate the flesh, right? X-rays can penetrate the flesh, right? X-rays can penetrate the flesh. Okay. Roentgen received the first Nobel Prize in physics. Roentgen හම්බෙලා මේකට Nobel Prize එක. මේ වැඩේට Nobel Prize එකක් හම්බෙනවා. හරි. අපි ඊළඟට. Right, next one. Right. අපි ඊළඟට move වෙනවා. Radioactivity. Right. බලා ගන්න. Radioactivity. What is radioactivity? Radioactivity is the process by which, right? බලා ගන්න හොඳට. Radioactivity is the process by which unstable atomic nuclei emit particles or energy to become more stable. Radioactivity is the process by which unstable atomic nucleus emit particles or energy to become more stable. Particles or energy to become more stable. Radioactivity is the process by which unstable atomic nuclei emit particle or energy to become more stable. Radioactivity. So these kind of definitions may ask for your first term test. So you need to remember. So what is radioactivity? So I'll explain a little bit this one. Right? When we right here, when the number of proton increase inside the nucleus. So let's think this is a nucleus. When number of proton increase, right? When number of proton increase, also number of neutron increase, you know, right? You know, when number of proton increase, also number of neutrons increase, right? When number of proton increase, when number of neutrons also increase. But when the number of proton increase more and more, right? More and more, the repulsions between proton and proton increase. The repulsions between proton and proton increase. So when the number of proton increase, the repulsion between proton and proton increase, the nucleus will get unstable. In that case, nucleus will get unstable. in that case, nucleus will get unstable. Nucleus will get unstable, right? In that case, nucleus will get unstable. Nucleus is unstable now. So to regain the stability, the nucleus will emit particles of energy. So by emitting particles of energy, the nucleus becomes stable. So you know that when we right, in the nuclear reactions, we get unstable nucleus, right? And then the unstable nucleus will emit certain radiations to become more stable. Unstable nucleus will emit certain rays to become more stable. To become more stable. So the radioactivity is the process by which unstable atomic nucleus emit particle energy to become more stable. The emitted radiation may be particles like alpha and beta, or high energy electromagnetic radiation like gamma. High energy radiation like gamma, right? High energy radiation like gamma. Right? High energy radiation like gamma, right? And then here the discovery of radioactivity. The discovery of radioactivity. The discovery of radioactivity. Discovery of radioactivity. Right. Here, discovery of radioactivity. You may heard about Marie Curie and Pierre Curie. අහලා නේද? එන ඔන්න මුල මේක මේකත් මතක තියාගන්න ඕනේ බලන්න. What is radioactivity and discovery of radioactivity? මතක තියාගන්න ඕනේ. Radioactivity was discovered in 1896 by Henry Becquerel. Henry Becquerel. Radioactivity discovered by Henry Becquerel. Radioactivity discovered by Henry Becquerel. මතක තියාගන්න. Radioactivity was discovered in 1896 by Henry Becquerel. Discovered by Henry Becquerel. වැඩි උනේ මේ ටික ඕනේ නෑ but පොඩ්ඩක් බලමු. So we need to remember the name of the scientist who discovered the radioactivity. We need to remember what is radioactivity, and we will remember the name of the scientist who discovered the radioactivity. Who discovered the radioactivity? Right. Radioactivity was discovered by Henry Becquerel. While studying uranium salt, he placed them on photographic plates wrapped in a black paper. Even without exposed to light, the plates become exposed, showing that uranium emits invisible radiations later called Becquerel rays. So normally, to create nuclear weapons, we use uranium, right? And from using uranium, the Becquerel initially discovered the radioactivity using uranium, right? Using uranium salt, certain uranium salts, and we do not need to learn much things regarding radioactivity for A levels, but you will learn that later for your physics. As I remember, the last unit of the physics paper, and there is some the nuclear reactions, radioactivity, like all the things you have to learn. And here we go through the discovery of the radioactivity, Henry Becquerel, and then he used uranium salt to discover the radioactivity. Later, these rays called Becquerel rays. The next thing is the work of Marie and Pierre Curie. The work of Marie and Pierre Curie. The Marie and Pierre Curie further studies this radiation and name the phenomenon, right? Name the phenomenon. The Marie Curie, right? Marie Curie won the Nobel Prize. Marie Curie. So write this: Marie Curie. Curie won won the Nobel Prize in physics. In physics with Pierre Curie and Becquerel. Right. She later won the Nobel Prize in chemistry for isolating pure radium. මාර්කෙට Nobel Prizes දෙකක් හම්බ වෙනවා. එකක් තමයි for physics වලට හම්බ වෙනවා. අනිත් එක chemistry වලට හම්බ වෙනවා. Right. එයා physics වලට අනිත් එක chemistry වලට. Right. Marie and Pierre further studied the radiation and named the phenomenon. So Marie Curie won the Nobel Prize for physics, and later she won the Nobel Prize. Later she won the Nobel Prize for chemistry for isolating pure radium. ඔන්න ඔය කාරණා ටික. Right. අපි යනවා ඊළඟට. The next one. Rutherford discovered of 3 types of radiations. ඊළඟ එක්කෙනා. Rutherford discovered 3 types of radiations. Right. Questions තියෙනවා නම් දාන්න. Right. So X-rays cause cancers. Yes. So if you expose to more, it may cause cancers. Right. So there is certain values, the certain threshold values there. So for your physics, you will calculate the how much radiation cause the cancer, and likewise there are certain calculations. But for chemistry, for the first unit, we do not do such calculations. Right. Yeah. And then Rutherford discovery of 3 types of radiation. Rutherford discovered of 3 types of radiation. If you remember about Rutherford was with the Thomson the previous week. කලින් දවසේ එක බලන්න. Thomson, J.J. Thomson introduced the plum pudding model. Right? J.J. Thomson's atomic model is a plum pudding model, and Thomson's student is Rutherford. Rutherford conduct experiment regarding atomic structure. Rutherford conducted experiments regarding atomic structure. Rutherford conducted experiment regarding atomic structure. ගැන experiment කරා. ඊළඟට ඒ විතරක් නෙමෙයි, දැන් Rutherford discovery of 3 types of radiation නේ. එතකොට Rutherford යනවා මෙන්න මෙහෙම වැඩක් කරනවා Rutherford. හරිද? එයා යනවා මේ කවුද? එයා ideas ගන්නවා radioactivity අපි කතා කරන්නේ. Radioactivity. So he get the idea from the radioactivity, and he discovered 3 types of radiations. And those three types of radiations called alpha, beta and gamma radiation. Right. ඔන්න එනවා මතක තියාගන්න ඕනේ. Ernest Rutherford discovered the 3 types of radiations. Highlight කරලා තියාගන්න. Ernest Rutherford discovered the 3 types of radiation: alpha, beta and gamma. Right. Ernest Rutherford discovered radioactive substance emit 3 different type of radiation: alpha, beta, gamma. Those are the alpha and beta and gamma. Alpha, beta, gamma. Those are the alpha, beta, gamma. Right. Those are alpha, beta, gamma. Rutherford discovered 3 types of radiation: alpha, beta, gamma. අද අපි lesson එක ඉවරලා questions කරනවා, past paper questions. ඒ නිසා මේක පොඩ්ඩක් touch එකේ තියාගන්න. මේ ටික exam එකට අහලා තියෙනවා. ඒතර ඔයාලට idea එකක්, so we can get an idea about the things that what we need to remember to get marks for A levels, right? So we will do the theory and later we will do the questions. So when we do the questions, you can get an idea. So what you need to remember from this first unit, right? So let's talk about alpha, beta and gamma radiations. Rutherford observed that the radioactive substance emit positive charged particles. Positive charged particles. Positive charged particles. Emit positive charged particles. Positive charged particles. Right. Rutherford observed that radioactive substances emit positively charged particles. These particles are easily stopped by paper or thin metal sheets. They were named alpha particles. Later, it was discovered that alpha particles are helium nuclei. Helium nucleus. I'll explain these things, right? About alpha particles. අපි alpha particles ගැන කතා කරමු. Right. Let's talk about alpha particles. Okay. Let's talk about alpha particles. Right. Now let's talk about alpha particles. Alpha particles. Right. So yeah. Alpha particles. Okay. Let's get, yeah, alpha particles. Right. Alpha particles. Hope you can, yeah, can you see this one? Right. Alpha particle, normally we name plus 2 and 4 here. Plus 2, 4. එහෙම නැත්නම් we can denote alpha particles alpha, we can denote alpha particles alpha 2, 4 plus 2. In other case, alpha particles are the helium nucleus 2, 4, 2 plus. 2, 4, 2 plus. So I'll explain how alpha particles equals to helium nucleus, right? So what is helium nucleus? Let's consider yeah, helium nucleus. Helium 2, 4. What is inside the helium? Helium atom. Inside helium atom, there are two protons and two neutrons. There are two neutrons, two protons and two neutrons. And outside the nucleus, there are two electrons. Outside the nucleus, there are two electrons. After helium remove two electrons, after helium remove two electrons, only two protons and two neutrons, only two protons and two neutrons remain. Two protons and two neutrons remain. Only two protons and two neutrons remain. So when there is protons are positively charged, as you know, protons are positively charged. So the protons, there are two protons and two neutrons, therefore mass number is 4. Now there is 2 plus charges there and there is 2 removed electrons. 2 electrons removed, right? Therefore 2, 4 plus 2 mean alpha, 2, 4 plus 2 mean helium nucleus. So we can say alpha particles are helium nucleus. Alpha particles are helium nucleus. We can say that alpha particles are helium nucleus. Alpha particles are helium nucleus. Now, since the alpha particles are helium nucleus, we know alpha particle contain a mass. The relative mass is 4. Alpha particle relative mass is 4. Then let's go to beta particle. Let's go to beta particle. Normally beta particles we denote -1, 0. Normally beta particles we denote -1, 0. Or else we denote this one beta particle, right? Beta particle here -1. Beta particle here -1. As you know, we denote electrons also -1, 0, -1, 0. So beta particles are electrons. Beta particles are electrons. Now what we can tell about these alpha particles are positively charged. Alpha particles are positively charged. We can say alpha particles are positively charged, right? Contain a mass. Alpha particle contain a mass. Positively charged, contain a mass, and alpha particles are the helium nucleus. Alpha particles, we can call alpha particles as helium nucleus. So when it comes to beta particles are negatively charged, right? Mass is be considered nearly equal zero, but we know electron contain a mass. Electron contain a mass. Therefore, we cannot say the mass is zero, but mass is nearly equal zero. We can say mass is nearly equal zero, but that is not zero. But that is not zero. Nearly equal zero, but that is not zero for beta particles. Beta particles. So alpha particle, beta particle, and then let's go to gamma. Gamma rays. Gamma rays. These are not particles. These are energy beams, right? Energy beams. We call electromagnetic electromagnetic rays. Electromagnetic rays. Alpha, beta, and then gamma. Gamma means electromagnetic rays. Electromagnetic rays. Mass is zero. Mass is zero. Charge is also zero. So let's make a summary table. Alpha, beta, gamma. Right. Alpha 2, 4, 2 plus. Beta -1, 0. Alpha mean helium nucleus 2, 4, 2 plus. Beta mean electrons. Gamma mean electromagnetic radiation. Electromagnetic radiation. Gamma mean electromagnetic radiations, right? And then, right, let's make a summary here. So what is the charge? Let's consider charge. Charge. So let's consider relative charge, not the actual charge. Let's consider relative charge. Let's consider relative charge. So we will so we have to talk about the relative charge and all the things later, right? Relative charge and all the things we have to talk it later, right? Marie Curie and Curie twins නෙමෙයි. හරිද? මේ husband and wife. Positron කියන්නේ beta particles නෑ. Positron කියන්නේ beta particles නෙමෙයි. අපි ඊළඟට කතා කරනවා positrons ගැන. හරි? අපි ඉස්සරහට කතා කරන්න ඊළඟ note එකේ ඉස්සරහ තියෙනවා positrons and all the things we are going to discuss, right? මේ කවුද? Marie Curie කියන්නේ husband and wife. හරි? ඊළඟට බලමු. Right. ඊළඟ එක්කෙනා මොනවද අපි කතා කරේ relative charges. Relative charges. Right. Relative charges. Relative charge is +2. Relative charge is +2. Relative charge is -1. No charge 0. No charge 0. Relative charge is 0. Relative charge is 0. Marie Curie, right? Pierre Curie, ඕම ගියා. දැන් අපි ආව radioactivity වල alpha beta gamma. Who discovered the alpha beta gamma? Rutherford. Rutherford discovered the alpha beta gamma. Rutherford කියන්නේ කවුද? Rutherford is student of J.J. Thomson. Rutherford is student of J.J. Thomson, right? ඊළඟට relative charge. ඊළඟ අපි යනවා relative mass. relative mass. Relative mass is 4. Relative mass is nearly equal 0. Right? Meagan 0 ma tamai. Relative mass is 0. So relative charge, relative mass. So these are the main thing. ඉතින් අපිට මෙයාලා කතා කරන්න තියෙනවා. මෙන්න මෙහෙම එකක්. Right? ඔන්න alpha beta, when we consider alpha, beta and gamma rays. Alpha, beta and gamma rays. Alpha, beta and gamma rays. Right? In this way, when we go to alpha, beta and gamma, alpha, beta and gamma. අපි na gamma to beta, beta to alpha වගේ අපි. Right? So let's consider the other way. Right? Alpha, then beta, then gamma. Let's consider in this way, right? Left to right. So when we move left to right, alpha, beta and gamma. So what we can tell about the masses? Alpha 2, 4, 2 plus, minus 1, 0, 0, 0, right? Then when we go to left to right, mean alpha, beta and gamma. We go to alpha, beta and gamma. We go to alpha, beta and gamma. Alpha, so what we can tell about mass? Mass increase or decrease? When we go to here, mass decrease. Mass decrease, right? When mass decrease, we can say speed decrease. When mass decrease, speed increase. When mass decrease, mass එක අඩු නම් යාගේ speed එක වැඩි. Speed increase. Mass decrease but speed increase. Mass decrease, speed increase. මට මතකද දන්නේ නැහැ මම කලින් දවසේ මෙන්න මෙහෙම sentence එකක් කිව්වා. Anything which contain a mass cannot go at the speed of light. Anything which contain a mass cannot go at the speed of light. Anything which contain a mass cannot go at the speed of light. මතක තියාගන්න. එහෙනම් when mass decrease, speed increase. මෙයා gamma rays travel at the speed of light. Gamma rays අපි මෙතන ගමු speed වගේ එකකුත් දාගමු. Speed, right? Speed එක මෙයා light speed එකේ යනවා. Light speed. Less than light speed, less than light speed. Less than light speed. මෙයා less than light speed. Light speed. Less than light speed. Right. ඊළඟට when the mass decrease, speed increase. There is one thing, right? When mass decrease, speed increase. Mass decrease, speed increase. The other thing is mass increase. When the mass decrease, speed increase. Right. Then what we can observe here when we go alpha to beta, beta to gamma, charge. Charge මොකද වෙන්නේ? Charge decrease. Right? When charge decrease, we can say, right? When charge decrease, we can say ionizing power. Right? Ionizing power. You can say ionizing power. Questions තියෙනවා ionizing power. When charge decrease, ionizing power decrease. Ionizing power decrease. ඔන්න ඊළඟ fact එක බලන්න. Anything which contain a charge contain ionizing power. Anything which contain a charge contain ionizing power. මෙතන ලියන්න. බලනවා. Anything which contain a anything which contain a charge, anything which contain a charge contain ionizing power. contain ionizing power. Ionizing power. Anything which contain a charge contain ionizing power. කලින් දවසේ මොකක්ද කිව්වේ? කලින් දවසේ මෙහෙම එකක් කිව්වා. Anything which has a mass cannot go at the speed of light. At the speed of light. At the speed of light. Anything which has a mass cannot go at the speed of light. Then මොකද්ද? Anything which contain a charge contain ionizing power. Then what is ionizing power? Ionizing power කියන්නේ ඔබ සරලව ගත්තොත් මෙහෙම එකක්. හරි. සරලව ගත්තොත් it means when this radiation collide on certain gas particle, when certain rays collide on certain gas particles, right? So this is a nucleus and there are electrons around the nucleus. When these certain rays which contain a charge collide with the electrons, they can eject the electrons from that at certain gas particle. So this gas particle become ions. So that is what we call ionizing power. Anything which contain a charge contain ionizing power. It means if something contain a charge, when they strike with certain gases, they can eliminate electron from that certain gas. Finally, the gas become ions. So we call ionizing power. Then if something contain a charge, means the certain rays contain a charge, the charge rays collide with certain gases, the gas will ionize. Right? Charge decrease with the ionizing power decrease. There is no charge, no ionizing power. No charge mean no ionizing power. Gamma consider karama, right? No ionizing power. Do not contain ionizing power. No ionizing power. And no charge, no ionizing power. No charge, no ionizing power. No charge, then no ionizing power. No ionizing power. No ionizing power. No ionizing power. No charge, no ionizing power. No charge, no ionizing power. Right? And then, right, what we can tell about here. So you need to remember these things, right? I will send the PDF of this written note also. So what we need to remember, right? So when we consider alpha, beta and gamma, when we move to alpha to beta to gamma, mass decrease. When mass decrease, speed increase. Right, that is it. When charge decrease, maybe there are no charge decrease. When charge decrease, ionizing power also decrease. Ionizing power decrease. Mass decrease, speed decrease. Charge decrease, ionizing power decrease. So those are things you need to remember. Medical, those are the things you need to remember from this part, right? So can these rays, X-rays go through human body, and also gamma rays are electromagnetic radiations. They also can go through the human body, and also we have to learn the penetration power of these things, right? Now I'm going to talk about that one. Penetration power. On the question, we have to learn that part. Also, right? Right? ඔන්න වැඩේ penetration power කතා කරමු. Penetration power. ඒ එන්නේ මෙන්න මෙතනට. Penetration power, right? එතනින් මම ලියනවා. Penetration power, red color එකෙන් ලියමු. Penetration power, right? So what we can tell about penetration power? penetration power. Penetration, what we can tell about penetration power, right? What we can tell about penetration power. Penetration power. When the mass decrease, speed increase. When speed increase, penetration power increase. Penetration power increase. Penetration power increase. Penetration power mean හිතන්න මෙහෙම ග්ලාස් එකක් තියෙනවා. ඔයාලා ග්ලාස් එකක් හිතන්න. top එහෙම කියන්නේ slow speed එකේ ගිහලා ග්ලාස් එකේ ඔයා වදිනවා ග්ලාස් එකේ. ග්ලාස් එකේ ඔයා මීට ගිහලා වදිනවා. Penetrate and you cannot go through the glass. or glass එකේ වදිනවා ගිහලා very high speed. Glass will what happen? So you can penetrate glass එක කඩාගෙනනේ යන්නේ අපි. හරිද? ඒ වගේ අදහසකින් ගන්නකො. මේක කතා කරන්නේ අර කඩාගෙන යන එකක් නෙමෙයි penetrate වෙන එකක්. ඔයාට ඕක ගැන ඔයාලා ඔබ්සර්වේෂන්ස් තියෙනවා මේ X-rays use කරලා. ඒ කියන්නේ X-ray අර lights තියෙන්නේ X-ray light එකක් අරන් ඔයා අර ඔයාගේ පොතේ තියෙන සුදු පාට කොලයකට තිබ්බහම X-ray එකේ ඒ paper එක through යනවා penetrate වෙනවා. අන්න ඒවට අපි කියනවා penetration power කියලා. දැන් ඔය glass එකක් through light එන්නේ visible light penetrate වෙනවා. කියන්නේ glass එකට හානියක් වෙන්නේ නැහැ but penetrate වෙනවා. That is we call penetration power. When the speed increase, penetration power increase. When the speed increase, penetration power increase. දැන් මෙයාගේ දිනව ගොඩක් ලොකු penetration power එකක්. gamma rays penetration power. Very high speed එක travel කරන energy එක වැඩි. Penetration power also increase. එහෙනම් ඔන්න මතක තියාගන්න. Mass decrease, speed increase. When speed increase, when mass decrease. When mass decrease, speed increase. When speed increase, penetration power increase. When speed increase, penetration power increase. Right. Here charge decrease. When charge decrease, ionizing power decrease. Right. Gamma, no ionizing power. No charge mean no ionizing power. Right. So those are the basic facts about right certain radiations. So we go to this one, the note, and then let's talk about the few things regarding the node. And let's wait a few minutes until this one. Right. So let's save this one. Okay. Right. Right. So we talk about initial things, these things, right? Right. So let's wait until this one settle down. Right. Until then, tell me whether right now we have started. So next week onward, so we are going to officially start the class, right? So I have send you the what link of the video right. I have sent you the link of the video that how you can register in our site. So once you register, so you will receive these all the tunes, right? So we will get your address and we will send you all the tunes and all the things, right? And also you can use that site to watch videos and get tutorials, and we will upload certain quiz, so you can write the answers and send through the site and all the things. So the students who are willing to join with me with my class, you can register, right? Register වෙන්න පුළුවන්. ඒකට අපි දාලා තියන්නම් ඔයාලට මම මේකට දැන් දාන්නම් registration video එකේ link එක. ඔයාලට ඒකට join වෙන්න පුළුවන්, register වෙන්න පුළුවන්. right. මේකට අපි දාන්න. right. all right. copy So මම comment section එකට දාන්න. අර ඒක use කරන්න පුළුවන් video එක. Right. Wait. Right. Okay. So then tell me if you have right. Okay. So let's start the remaining part, right? අපි ඊළඟ part එක පටන් ගමු බලන්න. Right. We discussed about certain rays, alpha particles, beta particles, and gamma particles. Alpha, beta, gamma. මේ ටික ගැන අපි කතා කරලා තියෙනවා. මේ ටිකත් අපි කතා කරා. අපි යනවා ඊළඟට Thomson's plum pudding model. Thomson's plum pudding model ගැන කතා කරන්න යන්නේ. Right. Thomson's plum pudding model. Okay. අපි Thomson plum pudding model එක ගැන කතා කරමු. Thomson's plum pudding model. Right. ඒතර අර කලින් ඒවා ටික මතක තියාගන්න. Lesson එකේ අපිට තියෙනවා pages 1 this one Thomson plum pudding model, mass of an electron and atomic mass unit, atomic weight එක ගැන පොඩ්ඩක් තියෙනවා, Rutherford nuclear model ගැන තියෙනවා, structure of the atom තියෙනවා, and discovery of the proton and questions. ඊළඟට අපිට questions කරන්න තියෙනවා. right. so පොඩි කොටසක් තියෙන්නේ. අද අපි මේ කැල්ල ඉවර කරගන්නවා. questions ටිකත් අපි කරනවා. නිසා හොඳට අහගෙන ඉන්න. පාඩමේ සෑහෙන කොටසක් අදින් ඉවර වෙනවා. right, let's start. Okay. So we were here. Thomson's plum pudding model. Right. Hope you all know Thomson's plum pudding model for your O levels. Thomson's plum pudding model. දන්නවනේ. Thomson's plum pudding model. Right. Shall we start? Thomson's plum pudding model. Okay. Thomson's plum pudding model. Right. මෙයා මෙහෙම කතාවක් කියනවා. Atom is positively charged sphere with negatively charged electrons embedded in it. Electrons like plums, right? And the positively charged sphere is pudding. මෙහෙම එකක් ඔක හරියටම ගත්තොත් නම් කියනවා Thomson's කියනවා Thomson plum pudding model. So we can consider a certain, right, this is positively charged sphere. All of this, right, positively charged sphere, all the part here is positively charged. This one is positively charged, completely positively charged. සම්පූර්ණයෙන්ම completely positively charged. This one is positively charged. So a bit more we can get accurately. Yeah, positively charged, right? Totally this one is positively charged. And Thomson proposed negatively charged particles are embedded within this one, like plums in a pudding. Plums in a pudding. Negatively charged particle. So my total, it's like totally this one is positive charge and the negative charge particles are embedded within it. And also the total amount of positive charge is equal to total amount of negative charge. You know? Positive charge is equal to total amount of negative charge. Total amount of positive charge is equal to total amount of negative charge. So that is a very simple thing, right? As සරලම දෙයක් කිව්වේ එහෙනම් නිකමට හිතන්න ඔයා ඒ කාලේ හිටිය කියලා. දැන් ඔය තොම්සන්ලගේ කාලේ ඔයා හිටියා නම් ඔයාට කියන්න තිබ්බ යාළුවාට මෙන්න මෙහෙම එකක්. ඇටම් කියන්නේ පුඩින් එකක් වගේ. atoms like pudding, right? The pudding is positively charged and the plums are negatively charged. Those are we call electrons වගේ කතාවක් වාට කියන්න පුළුවන්. And there are certain limitations. මේක දෙනවා limitations තියෙනවා. Right? Limitations. Did not explain the existence of protons. Failed to explain the Rutherford gold foil experiment. Couldn't explain atomic spectra. Did not explain how electrons remain stable. වගේ කතන්දර ටිකක් තියෙනවා. Right? So we have learned each of these, right, within this unit. Limitations also we have to talk about limitations in the other atomic structure, atomic models. Right? මේක සරල දෙයක් ඒක එතනින් ඉවරයි. අපි යනවා charge of an electron. Charge of an electron. Millikan's oil drop experiment. Charge of an electron was discovered by Millikan using oil drop experiment. Remember, මතක තියාගන්න. Charge of an electron was discovered, right, by Millikan using oil drop experiment. Charge of an electron was discovered by Millikan using oil drop experiment. Using oil drop experiment. මතක තියාගන්න. Using oil drop experiment. Charge of an electron was discovered by Millikan using oil drop experiment. එහෙනම් Millikan's oil drop experiment. මතක තියාගන්න. Millikan's oil drop experiment. Millikan's oil drop experiment. Charge of an electron was discovered by Millikan using oil drop experiment. Right. මේකේ අර මම පොඩි එක්ස්ට්‍රා දේවල් ටිකක් දාලා තියෙනවා. ඒ ටික අපිට ඕනේ නැහැ. Right. So what you need to remember is, right, what is the charge of an electron? Charge of an electron is minus 1.621 10 to the power minus 90. Minus 1.621 10 to the power minus 19. That is the charge of an electron. 1.6 10 to the power minus 19. That is the charge of an electron. That is the charge of an electron. That is the charge of an electron. මතක තියාගන්න. That is the charge of an electron. That is the charge of an electron. Right. That is the charge of an electron. 1.6021 10 to the minus 19. Actually, that Millikan discovered very accurately minus 1.529 10 to the minus 19, but later discovered 1.6021 10 to the minus 19, right? So we need to remember this one. Minus 1.6021 10 to the minus 19. That is what we need to remember, right? That is what we need to remember, right? And then here, so when we compare this one, when we compare the charge of an electron, when we compare charge of an electron, right, it is right, you know, for O level also we have to learn this one, 1 over 1840, 1840, the mass of hydrogen atom, right? He also calculated the mass of an electron, which is about 1 over 1840, the mass of a hydrogen atom. Right? When we consider the mass of an hydrogen atom mean the proton, when we consider proton, mass of proton, right? Mass of proton, hydrogen atom එකක් කියන්නේ ඔය proton එක mass එකත් එක්ක consider කරපුවාම, right? Proton mass එකත් එක්ක consider කරාම mass of proton කියලා අපි දාමු. hydrogen ion වගේ එකක් proton, right? Proton, when we compare with the proton, means hydrogen ion, the mass of an electron is 1 over 1840 nearly. So that is the case. මේ දෙන්න පොඩි picture එකක් oil drop experiment එකේ. Who discovered the charge of an electron? මේ charge of an electron discovered by Millikan. Charge of an electron discovered by Millikan. Charge of an electron discovered by Millikan. මතක තියාගන්න. Millikan. Right. Mass of an electron. mass of an electron. Mass of an electron. Right. Mass of an electron. The mass of an electron was determined by combining the results from J.J. Thomson's E over M value and Millikan's oil drop experiment value. J.J. Thomson discovered E over M value. J.J. Thomson discovered E over M value. Millikan's discovered charge of an electron. එහෙනම් අපිට පුළුවන් මේ දෙන්නේ Thomson's E over M value 1.76 10 to the power 11. 1.76 10 to the power 11. Then මෙයා 1.602 10 to the minus 19 තමයි charge එක. එහෙනම් අපිට පුළුවන් mass of an electron. We can do the calculation mass of an electron. How we can do the calculation? අපි ගමු mass over charge over mass ratio. So let's consider charge over mass ratio. E over M value. Let's consider E over M value of electron, and that is also equal to E over M value of electron. That is equal to E over M value, E over M value of electron. Right? E over M value of electron. E over M value is equal E over M value. Harini. E over M value is equal E over M value. Right. So let's subject here. Now we are going to measure the mass of an electron. Let's subject mass. Right. Mass. अभी subject करना. Mass. Mass is equal charge over charge over mass. Right. Charge over charge E over M. Got it? Mass. Let's subject mass here, red color mass. Charge over E over M. Right. Now let's calculate mass. Let's calculate mass. That is equal. We know charge of an electron. We know charge of an electron, that is equal 1.602 10 to the power minus 19 coulomb. And E over M value, what is E over M value? E over M value. E over M value 1.9. E over M value is equal 1. E over M value is equal 1.76. E over M value is equal 1.76 10 to the power 10 to the power 11. Right. 1.76 10 to the power 11. So when you calculate this one, so you will get 9.1 into 10 to the minus 31. 10 to the minus 31. So that is the mass of an electron. Mass of an electron is approximately 9.1 10 to the minus 31. This is about 1 over 1840. 1 over 1840. 1 over 1840. 1 over 1840 of the mass of hydrogen ion. Mass of hydrogen ion. Mass of hydrogen ion. Hydrogen ion mean proton. Hydrogen ion mean proton. Right. So that is the thing about mass of electron. Mass of electron. Right. මෙතන මම දාලා දෙනවා mass of an electron in atomic mass unit. Minus 4 වෙන්න ඕනේ. Calculation එකක් තියෙනවා. Normally we do the calculation in this calculation in unit 3. Unit 3 එකේ තියෙන්නේ මම දාලා තියෙනවා. වෙනවට පොඩ්ඩක් බලමු. Right. පොඩ්ඩක් බලමු. අපි මෙතන යුනිට් 3 වල පොඩි කැල්කියුලේෂන් එකක් දාලා තියෙනවා. මේක කොහොමද දෙලා අපි ඊළඟ පාර්ට් එකට යමු. right right මෙතන තියෙනවා early problem of atomic weight. So this one is out of syllabus, but to write the answer for the fast paper questions you need to remember the name of the scientist. Atomic weight relate with Cannizzaro. Atomic weight relate with Cannizzaro. That is it, but you need to remember. Atomic weight relate with Cannizzaro. Atomic weight relate with Cannizzaro. Atomic weight relate with Cannizzaro. That is it. But you need to remember Cannizzaro. Right. Atomic weight Cannizzaro. Then we go to Rutherford's nuclear model. Right. හොඳට අහගන්න Rutherford nuclear model ගැන කතා කරන්න යන්නේ. මේක හොඳටම අහගන්න ඕනේ. හරි. මොනවාරි questions තියෙනවා නම් දාන්න. questions නැත. okay. question නැහැ. Mind. Right. Right. question නැත. එහෙනම් අපි ready කරමු. Rutherford nuclear model. දැන් මේක තියෙන්නේ පොඩි story එකක් තියෙන්නේ. අපි let's go to the story. Rutherford nuclear model. Let's go to the story. Okay. Rutherford nuclear model. Right. වදන්නවා J.J. Thomson. Right. අපි කතා කරන්නේ J.J. Thomson ගැන. J.J. Thomson. Right. J.J. Thomson. Right. අපි කතා කරා J.J. Thomson ගැන. J.J. Thomson. මෙයා මොකක්ද කිව්වේ? plum pudding model එක ගැන කිව්වා. J.J. Thomson කතා කරා අපිට plum pudding model එක ගැන. plum pudding model. And now we are going to talk about Rutherford atomic model. Now we are going to talk about Rutherford's atomic model. Right? Rutherford mean Rutherford, you know, Ernest Rutherford. Ernest Rutherford, right? Ernest Rutherford. Ernest Rutherford. He introduced Rutherford nuclear model. මෙයා කියනවා nuclear model. Rutherford nuclear model. Right. J.J. Thomson's student is Ernest Rutherford. J.J. Thomson's student is Ernest Rutherford. J.J. Thomson conduct experiment regarding the structure of the atom. And Ernest Rutherford is J.J. Thomson's student, and he also conduct experiment regarding atomic structure. Further experiment regarding atomic structure. And Ernest Rutherford disproved the plum pudding model. Ernest Rutherford disproved the plum pudding model from his nuclear model. Ernest Rutherford disproved the plum pudding model using Ernest Rutherford's nuclear model. Right. And then there is another two scientists which scientists we call Geiger and Marsden. අපි ලියමු. Right. Another two scientists, right? Geiger and Marsden. Geiger and Marsden. Geiger and Marsden are Rutherford students. Geiger and Marsden, Rutherford students. Geiger and Marsden conduct experiment, right? We call Geiger and Marsden experiment, or we call gold foil experiment. Geiger and Marsden experiment, or we call gold foil experiment. We call gold foil experiment, or we call gold leaf experiment. Geiger and Marsden experiment or gold leaf experiment. Using the observations of Geiger and Marsden experiment, Rutherford introduced nuclear model. Using the observations of Geiger and Marsden experiment, Rutherford introduced nuclear model. Using the observation from the Geiger and Marsden or as gold foil experiment. Now we are going to talk about gold foil experiment. Are you ready? Now we are going to talk about gold foil experiment. Right. Shall we start gold foil experiment? Okay. Let's start the gold foil experiment. Nari. Gold foil experiment. Start gold foil experiment. The gold foil experiment is something like this. Gold foil experiment. අපි විනාඩියක් අරගෙන ඉස්සෙල්ලාම discuss කරලමුකෝ gold foil experiment. Before moving into this one, let's see whether we can go to, what is this one? Cancel. Not this one. Let's see that where we go. More apps. Peter Oni. Email. I need Chrome here, right? So okay, so you can use that but I have told you that simulation site, so you can go there and there are simulations, so we can use those simulations to get an idea about the gold foil experiment, right? We can get an idea about gold foil experiment. So give me, so I'll check whether it's available, right? Simulations, simulations, chemistry. Let's go with the, let's check whether gold foil experiment available. Yes, Rutherford scattering. Yes, it's available. Rutherford scattering is available. So yeah, I'll show you here. So let's try whether we can get the more apps. And give me one. Right here, browser is there. So let's browse it, right? Okay, let's go to Google and then search PhET Colorado. PhD Colorado. Here we are now. PhD. Right. Then PhD Colorado. Let's wait. Let's go to simulations. Chemistry. Simulations. And let's go to chemistry. chemistry simulations. Okay, happens. Something happens. Right. So here, below nucleus also there, right? Simulations. Let's keep this one here, and you also can check this one. Something wrong, I guess, but let's try to see that. Rutherford, here scattering. Rutherford scattering is there. Okay, so let's start this one. Rutherford scattering. Yeah, here this is plum pudding atom. Right, let's go to there. Yeah, this plum pudding atom. Thomson's plum pudding model. Right. So these are electrons. You can see here electrons and protons, neutrons, alpha particles, positive charge. So positive charge. Positive charge. Electrons are embedded within the positive charge particle. We energy minimum karana, so we can maximize the energy, right? Atomic scale එකක් තියෙනවා. So here we send the alpha particles යනවා. Plum pudding model. Plum pudding model එක අනුව alpha particles යනවා. Right. ඊළඟට next one. Now we are going to observe the Rutherford nuclear model. Rutherford nuclear model. Rutherford nuclear model is beta. Can you hear me? ඇහෙනවද බලන්න. Right, simulations, we go to simulations, chemistry, right, again this one. Right, Rutherford's atom. So here, so these are the atoms, right, according to Rutherford. Now this is, so we send alpha particles here, alpha particles up here. In this reaction we send alpha particles, right? Up here alpha particles here now. So let's trace the alpha particles. The alpha particles trace karo, right? The nucleus, electron energy levels and alpha particles, right here. So this is these are alpha particles. Protons and neutrons are there inside the nucleus. So you can trace here the path of the alpha particles. When we consider certain one nucleus, right? So let's think this is nucleus, and then we use accelerated alpha particles. When these alpha particles go near to this nucleus, due to the positive charge of the nucleus, alpha particles also positive charge. Alpha particles also positive charge. So they will deflect due to the proton-proton repulsion. Alpha particle will deflect. Alpha particle will deflect due to the proton-proton repulsions. Alpha particle deflect. So you can observe here, right? Alpha particle deflect due to the proton-proton repulsion. Alpha particle deflect, and most of the alpha particles go without any deviations. We can observe that one from here, right? So if we enlarge this one and get the nucleus smaller, and then you can observe here the most of the alpha particle, if we consider one nucleus, one certain nucleus, here most of the alpha particle go without any deviation. Most of the alpha particle go without any deviation. But the few alpha particles which travel near to this certain nucleus, they will deflect. They will deflect due to the repulsions of proton-proton repulsion. Positive charge repulsion, due to the positive charge repulsions, right? Positive charge repulsion means proton-proton repulsions, right? Alpha particles are positively charged. Alpha means helium nucleus. Here we use accelerated alpha particles. The alpha particle which travels close to the nucleus, they will bend. They will bend. But most of the alpha particles go without any deviation. Go without any deviation. But rarely, very rarely, when certain alpha particles directly strike on the nucleus, they will bounce back. They will bounce back. Very rarely, certain alpha particles strike. They will bounce back. Bounce back. At some point, certain alpha particle will directly collide and they will bounce back. It happens very rarely. It happens very rarely. It happens very rarely. It happens very rarely. So this is the alpha particle experiment. Rutherford alpha particle experiment or Geiger-Marsden experiment. Rutherford alpha particle experiment or Geiger-Marsden experiment. Right. Hope you get an idea. So I will increase the energy of the alpha particles. Let's increase the energy of the alpha particles. Right. They travels with very high speed. Right. Here you can observe, right? Here, when directly collide, strike on the nucleus, they will bounce back. And if we decrease minimum energy alpha particle, you can observe slowly they go and bounce back, right? Hope you get the idea how it works. Shall we move to the theory part? It's okay. Here, let's go to here. Alpha particle scattering. Alpha particles scattering. Here we use accelerated alpha particles. Accelerated alpha particles. Accelerated alpha particle. We need to get certain material which emit alpha particles. And normally we use lead cover. Normally we use lead cover. Right. Normally we use lead cover. Here and then we cover the radioactive material. So that radioactive material now emits certain rays. Radioactive material now emits certain rays. Right. This radioactive material now emits certain rays. Right. This will emit certain rays. It will emit alpha particles. It emits alpha particles. Emit alpha particles. Right. We use accelerated alpha particles. And then here we use thin gold foil. Thin gold foil. So let's get the gold foil, the thin gold foil. When these alpha particles strike with this thin gold foil, right? Inside this gold foil, there are certain atoms which you observe. There are certain atoms. Now what happens? Most of the alpha particles go through this gold foil without any deviation. Most of the alpha particles go through this gold foil without any deviation. The most of the alpha particles go through this one without any deviation. Without any deviation. But rarely a few alpha particles, few alpha particles, right? Few alpha particles bend with larger angles, right? Very rarely, right? Few අපි තුනක් විතර අඳිමු, right? Right. Very rarely, very rarely, alpha particle will bounce back. Very rarely. So how we identify this one? To identify these rays, normally we use a fluorescence screen. අපි use කරන fluorescence screen එක. When certain rays collide on certain fluorescence screen, it will give a certain color glow. කලින් දවසේ අපි previous week එකේ අපි කතා කරලා තියෙනවා. They will give a certain color glow. Right? It will give a certain color glow. It will give a certain color glow. Right. So this is our fluorescence screen. It's our fluorescence screen. Right. Now these rays collide with these fluorescence screen. They will give certain color glow. Glow they will give certain color glow. Using these glowing, we can identify the direction of the particles, directions of the alpha particles, right? So in gold foil experiment, there were mainly 1, 2, and 3. 3 observations. There were mainly 3 observations. First one, most of the alpha particle go through the gold foil without any deviation. Most of the alpha particle go through the gold foil without any deviation. Right. A few alpha particles, right? Few alpha particles bend. Few alpha particles change their direction and bend. That is second observation. Third one, very rarely, alpha particle bounce back. Very rarely. So those were the 3 main observations. By using these 3 main observations, Rutherford proposed his nuclear model. 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 Right. So let's go to the note. වැඩේ පැහැදිලිනේ. අපි note එකට යමු. Right. So that is the thing about Rutherford nuclear model. Rutherford nuclear model. වැඩේ තේරුණාද? So now, since the alpha particles, most of the alpha particles, right? Most of the alpha particles go through the gold foil without any deviation. Most of the alpha particle go through the gold foil without any deviation. From that observation, Rutherford predict most of the part of an atom is empty. Most of the part of an atom is empty. So what is the observation? What is the observation? Most of the alpha particle go through the gold foil without any deviation. Most of the alpha particle go through the gold foil without any deviation. From that observation, Rutherford predict that most of the part of an atom is empty. Most of the part of an atom is empty. And second observation, a few alpha particles change their direction and bend. The few alpha particle change their direction and bend. Right? From that observation, Rutherford predict that there is something which is positively charged. Right? There is something which is positively charged. That is why that alpha particle bend. When alpha particle go near to that positively charged place, due to the repulsion between positive charge and positive charge, alpha particle bend. Right? Due to the repulsions, alpha particle bend. And then the last one, third observation, very rarely, alpha particle bounce back. So from that observation, Rutherford predict that the mass of an electron is concentrated in very small area, very dense small area. Mass of an atom is concentrated into very small dense area. Right? Small dense area. So let's go to the note. Right. Rutherford gold foil experiment. Rutherford Geiger-Marsden experiment. Gold foil experiment. Geiger-Marsden experiment. Right. Gold foil experiment. Geiger-Marsden experiment. Right. Okay. So here we are. Rutherford nuclear model. Right. Rutherford nuclear model. Right. My observations been Ernest Rutherford proposed nuclear model of an atom based on the gold foil experiment carried out by Geiger and Marsden. In this experiment, alpha particles were directed at the thin gold foil, and their scattering was observed. Right. Scattering was observed. We can now make a පාවිච්චි කරේ. Right. Accelerate or ලියන්න පුළුවන් method. Right. Alpha particles were directed. අපිට කියන්න පුළුවන් in this experiment අපි කියනවා accelerated alpha particles were directed at thin gold foil and their scattering was observed. Key observation. Most alpha particles pass straight through the foil without any deviation. This showed that most of the atom is empty space. Some alpha particles were deflected at small angles. This indicated that positive charge is concentrated in a small region. And a very few alpha particles bounce back, larger deflection. This suggested that presence of a very small dense positively charged center. Right. Conclusions. The atom is mostly empty space. The positive charge and the most of the mass are concentrated in a tiny central nucleus. The electrons move around the nucleus. Rutherford nuclear model. Right. ඉතින් අපි යනවා structure of the atom. අපිට යන්න දෙනවා structure of the atom. මේක ඊළඟ දවසෙත් කතා කරන්න තියෙනවා. Structure of the atom. ඒකට බලන්න. Structure of the atom. ඒකත් අපි කරන්නේ structure of the atom බලන්නේ deflected angles මෙයාගේ deflected angles of the alpha particles. We use deflected angles of the alpha particles to measure the radius of the nucleus and the radius of the atom. Radius of the nucleus and the radius of the atom. Radius of the nucleus and the radius of the atom. We use the deflected angles of the alpha particles to measure the radius of the nucleus and the radius of the atom. Right. Limitations, could not explain the atomic stability, could not explain the atomic spectra. So we do not need to learn about these limitations now, because we are going to learn about these limitations in the next atomic model. Next atomic model is Bohr's atomic model. Bohr is students of Rutherford. Bohr is a student of Rutherford. Thomson's atomic model and then Rutherford nuclear model. J.J. Thomson and his students is Rutherford. Next comes Bohr's atomic model. Bohr is student of Rutherford. Students are set මේක කරගෙන යන්නේ. ඊළඟට discovery of proton. මේකත් මතක තියාගන්න. Discovery of proton. Rutherford bombarded nitrogen gas with alpha particles and observe the emission of hydrogen nucleus. Again, Rutherford alpha particle වලින් nitrogen gas එකට bombard කරනවා ගහනවා. and hydrogen nucleus emit වෙනවා. එළිය detect කරනවා. ඒවට කියනවා protons කියලා. The hydrogen nucleus is fundamental particle called the proton. ඒවට කියනවා protons කියලා. Charge is +1. Actual charge is +1.602 10 to the minus 19 coulomb. The actual charge of electrons -1.602 10 to the minus 19 coulomb. Actual charge of the proton +1.602 10 to the minus 19. Relative mass is 1. Actual mass is 1.67 10 to the minus 27. මේක ගැන අපි වෙනම ඊළඟට ඉගෙන ගන්න තියෙනවා. හරි. දැනට ඒ ටික අපි යනවා questions කරන්න. First question එක කොහොමද යන්නේ? ඒක ඊළඟ ටියුට් එකේ තියෙනවා. Radius එක ඕනනම් ඔයාලට කරන්න පුළුවන්. ඒකත් අපි තියලා atomic radius තියලා. Right. The mass of an electron is ඔයාලට ඒක ඕනනම් හොයන්න පුළුවන්. අපි ගණන් ටික තියලා. Question number 6. Sorry. Let's start from the question number 6. We have 15 minutes to do these questions. There are 20 questions. So we start from the 6th one and we try to do the questions, and we are going to discuss all the questions now. And you can start from the 6th question. Tell me the answer for the 6th one. So you can go through your notes, PDF and all the things, and check the answers and let me know in the comment section. Right. So give me the answers, right? Give me the answers for the questions, right? Answers then the matter. All right. I will show in that case until you do the questions. Here I have certain fields with me, right? So I will show these things and the things you will get once you register in our site. Okay. And so this is kind of summary note here. And this is the first day quiz, the 50 questions, and then this is the plan. So this tutor includes your timetables and study schedules and lessons, and all the things are there. And also past paper tutor. And then this one is a second one. Now we are talking about these questions are included in this tute, theory part and all the things. And there are few more tutes, so you will get once you register in our site. Okay. Let's go to the questions. So if you have complete the question, right? Hope you complete the question. Okay. So this is the tute, right? I'll use that one also. Right. The question number 6. The quantity of the electronic charge was experimentally shown by Millikan. Charge of an electron discovered by Millikan. Right. The confusion that existed among the chemists that early ages study of the chemistry regarding the concept of the atomic weight Cannizzaro. Atomic weight Cannizzaro. Out of syllabus, but let's remember the name. Atomic weight Cannizzaro. Right. Size of the atomic nucleus was first determined by making use of alpha particle scattering. Alpha particle scattering. Right. Alpha particle is scattering. Question number 9. Right. Question number 9. Baran. Question number 9. Give me the answer for the question number 9. Question number 9. What is the answer? Question number 9. Right. Question number 9. So we have 15 minutes to complete the other 11 questions. Correct. Right. Question number 9. Which one of the following statements concerning the particles used by Geiger and Marsden in the experiment that provide the basis for the nuclear model of the atom is most appropriate? Accelerated particles were used by Geiger and Marsden. Yes, accelerated particles, but accelerated alpha particles. Accelerated alpha particles were used by Geiger and Marsden. Cathode rays were used wrong. Accelerated cathode rays, you're wrong. Accelerated neutrons wrong. All of the above statement incorrect. Abhi meka alpha particles dala answer ko 1 ke laga. Accelerated alpha particles were used by Geiger and Marsden. Okay. 10th question. The scientist who disproved Thomson's plum pudding model of the atomic structure is Thomson's student, who's Ernest Rutherford. Thomson's student Ernest Rutherford disproved the plum pudding model. X-rays were discovered. Roentgen. X-rays were discovered by Roentgen, and he took the first X-ray photograph of his wife's hand showing the wedding ring. Story. Right. Question number 11. X-rays were discovered by Roentgen. Question number 11. Question number 12. Which one of the following statement concerning alpha rays is not true? Alpha rays is not true. Alpha rays is not true. Alpha rays is not true. Right. The penetrating power of alpha rays is low. The penetrating power of alpha rays is low. Alpha rays will penetrating power. Alpha rays contain a mass. Penetrating, when the mass increase, penetration power decrease. Penetration power is low. That is correct. The ionizing power of alpha rays is high. Yes. Alpha rays contain higher charge, high ionizing power. Alpha rays travel with the velocity which is almost equal to that of light. Alpha rays travel with the velocity which is almost equal. That is wrong. Therefore, that is correct. Wrong. Therefore, that is correct. Anything which contain a mass cannot travel at the speed of light. Alpha ray contain a mass, so it cannot go at the speed of light. The path of alpha rays is changed by electric field. The path of alpha rays is changed by magnetic field. Anything which contain a mass deflected by magnetic field and also electric field. Anything which contain a mass can deflected by magnetic field and electric field. anything which contain a mass deflected by magnetic field and electric field. Anything which contain a mass deflected by magnetic field and electric field. Anything which contain a mass deflected by magnetic field and electric field. Hari, එකත් හරි. So these two are correct, therefore that is wrong. Alpha rays travel with a velocity of is almost equal to light, that is wrong, therefore that is correct. They ask, not true. Third one. 13, question number 13. The gold leaf experiment done by Rutherford using alpha particle explain that. What is the answer? Question number 13. What is the answer? Question number 13. Question number 13. Right. Answer again. Question number 13. Right. Question number 13. Question number 13. The gold leaf experiment done by Rutherford using alpha particles explain that the atom consists of electron. The mass of the atom is concentrated into a point that the volume of it is very small. Yes. Atoms are building units of matter. Neutrons are found in atom. Only B is correct. Answer is 5. Only B is correct. Answer is 5. If AB correct, answer is 1. If BC correct, answer is 2. If CD correct, answer is 3. If AD correct, answer is 4. If any other combination, answer is 5. Answer is 5. Right. Question number 14. Rutherford gold leaf experiment revealed that quite a larger space of a matter is empty. Yes. The positive charge is concentrated as nucleus. Yes. Only a thin layer can radiate alpha particle. Thin layer, thick layer, gold foil he didn't use. To check this one, we need to use different thickness of gold foil. He used thin gold foil and did certain experiment. There was mainly 3 observations, and this was not an observation. Electrons move in quantize and quantize katawa Q A and B correct. Answer is 1. A and B correct. Answer is 1. The true statement regarding alpha particle. Alpha particle take up electrons, make helium molecules. Oka hari. Alpha particles take up electrons. Remember, alpha particles 2, 4 plus 2. Electrons then get 2 electrons and become alpha 2, 4. Again, alpha mean helium nucleus. No? Helium 2, 4, 2 plus, and get 2 electrons. And converts to helium 2, 4. Therefore, alpha particle take up electrons to make helium molecules. That is correct. The penetration power of alpha particle is very small. That is correct. The ionization power of alpha particles is very small. Rho. Ionization power of alpha particle is very high. Because charge is high, ionization power is high. Alpha particles move towards N pole in a magnetic field. Nah. Anything which contain a charge deflect perpendicular to magnetic field. It means when with 90-degree angle, they will not attack towards N pole, lowest pole. A and B correct. Answer is 1. Question number 15. Answer is 1. Question number 16. Which of the following statement about alpha particle is a true? Right. Alpha particles have higher penetrating power than beta particles. No. Alpha particles have higher mass, low speed, low penetration power than beta particles. Alpha particles have higher mass, lower speed, lower penetration power than beta particles. Alpha particles have higher ionizing power than beta particles. Yes, alpha particles contain higher charge than beta particles. Therefore, when the charge increase, ionizing power increase. Alpha particles produce helium gas. Yes, kaling kata karan. Alpha particles are not deflected by a magnetic field. That is wrong. Alpha particles, charged particles, they deflected by 90-degree angles. A and B correct. Answer is 2. A and B correct. Answer is 2. Question number 17. Next one, question number 17. Which of the following statement concerning alpha, beta and gamma rays correct? The path of the alpha rays is changed by magnetic field. The path of alpha rays changed by magnetic field. Yes, alpha rays contain a charge. They deflect by magnetic field and also electric field. The path of beta rays is changed by electric field. Yes, beta rays also contain a charge. Therefore, they will deflected by magnetic field or electric field. The ionizing power of gamma rays is very high. Very high. Gamma rays do not contain any charge. So, no ionizing power. That is wrong. The penetrating power of alpha rays is very high. No, very low. Very low. Since alpha rays, mass of alpha rays higher, speed is lower. When speed lower, penetration power lower. And answer is 1. Answer is 1. Question number 18, 19 and 20. Question number 18, 19 and 20. Right, last 3 questions. මේ ටිකත් කරලම class එක ඉවර කරමු. Right. So question number 20. We did the certain theory part and we did certain questions regarding past paper questions. Right, past paper questions. Answers ටික බලන්න. Right. Then term test එකේ වැඩිම ලකුණු ගන්න ඕනේ. So we need to get a higher mark in first term test. That is very much important. That is much more important, right? So let's try to get higher marks in first term test. Final term test එකේ වැඩිම ලකුණු ගන්න try එකක් දෙමු. ඔයාලට දෙනවා ලොකු periodic table එකකුත් දෙනවා. Right? ඒ ටික register වෙන්න site එකේ අපි ඒ ටික එවන්නම් ඔයාලට. Right? Next week class පටන් ගන්නවා properly. එතකොට site එකේ register වෙන්න. Okay. The penetration power of alpha particle is greater than beta particles. Penetration power of alpha particle is greater than beta. No, alpha particle contain higher mass, lower speed, lower penetration power. Therefore, first one is wrong. The mass of the alpha particle is very much greater than the mass of the beta particle. Yes, yes. Correct. Answer is 4. Answer is 4. कौन मेरे answers करने? The answers got first statement correct, second statement correct, second statement explain first one, answer 1. First statement correct, second statement correct, second statement will not explain the second statement, answer is 2. First statement correct, second statement wrong, answer is 3. First statement is wrong, second statement is correct, answer is 4. Both statements are wrong, answer is 5. Answer is 5. Right. First one incorrect, second one correct. Incorrect, correct, fourth one is the answer. The atomic mass is accepted. The atomic mass unit atomic mass unit accepted as 1.66 10 to the minus 24 gram. That is correct. While the exactly 1/12 of the mass of the carbon atom is taken, make a carbon as the atomic mass unit. Exactly 12 grams of carbon. Carbon 612 කියලා දීලා නැහැ. ඒක නිසා මේක වැරදි. අපි ඕක third unit එකේ කතා කරනවා. Wrong. So answer is 3. Right. Question number 20. Question number 20. The ionizing power of alpha particle is greater than the ionizing power of the beta particles. Ionizing power of alpha, yes, higher charge, higher ionizing power, correct. The mass of the alpha particle is very much greater than the mass of the beta particle, yes. But second one will not explain. The reason for this first one is the higher charge, but they say about the mass. But mass is not related with the ionizing power. Charge is related with the ionizing power. Therefore, there is no relationship. Therefore, answer is correct. Both are correct, but second one will not explain the first one. Answer is 2. So that is it. මේ දෙන්නේ මේ part එකෙන් questions වලට අහපු ඒවා. there's a day quiz. Question. There are 15 questions. You can try it, those 15 questions also. So I will send you the answers for those 15 questions. So for today, class is over, and then we will do the class next part next Monday. So hope you study the previous things very well and be prepared. So in next class also we will be doing some few more questions, past paper questions. Inside good luck. See you in next week. Good night.